Hello, my name is Corey Lanham. I'm here to talk about graphs over space and time. It sounds like a pretty lofty concept, but really what we're talking about is what do we do with graph data that has a time dimension, a location dimension, or both? And how do you represent that in a visualization such that it can make sense to end users? So how do we actually visualize graph data that's in CosmosDB? Typically, you expect something like what you see on the left here, which is a very neatly organized, clustered graph visualization that helps you better understand the data that you're looking at and is perfectly intuitive. But what you more often get is something on the right, what we call a hairball, which is a clustered mess of nodes and links that nobody can really make sense of or understand what they're looking at. Or something like this, where you have so many links between the same two nodes that it doesn't help you understand what you're seeing at all. Or something like you see on the right, where you're trying to understand something about the geospatial dimension of your graph data, but there are so many links between the nodes are too large over the top of a map that it becomes difficult to really know what you're looking at all. So what we're going to talk about today is sort of the what, the when, and the where of graph data. The what is probably what you're most familiar with already, and that is a node link visualization, which shows off which nodes are connected to which other nodes. The connections in your data elements are what make up a graph to begin with. And that's really a very intuitive way of understanding those types of connections, is to draw them as a node link visualization. And graph data is very good at showing that what. However, the when and the where are things that we haven't really addressed in graph data quite yet. So what I'm going to talk about today is some other strategies that we can use for trying to get at the when and the where of graph data. Graph data often has some sort of time element to it. Something happened, a connection happened at a specific point in time, and other connections may have happened before, simultaneous with, or after those. How do we understand that progression of events over time? When you're looking at a traditional node link visualization, you don't have that time data in an easily accessible way. And then we're going to talk about the where. Oftentimes, the nodes in graph data have some sort of location component. This is an address, or a house that happens to be at a certain spot on the globe, or a corporation which is based somewhere, or a phone call where the user who placed the phone call was at a location when they did so based on their cell tower data, for example. So what we're going to do is we're going to talk about different ways of showing that time and that space dimension in your graph data. Now, there's also the how and the why, of course, but those are really more up to you. I can't help you with those. That's kind of what you're trying to uncover when you look at graph data across both the what, the when, and the where. So by doing so, I've created an example where I've taken data from cricket matches. Now, I'm an American. Cricket doesn't mean a whole lot to me. The concept of wickets and runs and innings and outs and all of that doesn't really ring true to me, but I don't have to understand it. Basically, what the data is it's about 3,800 different international cricket matches. I've taken all of that data, put it into CosmosDB as a graph. So the nodes themselves are the teams that are playing, and there aren't that many properties on each team, just the team name itself. Where most of the enrichment of the data comes from is from the links. So a link is a match. One team plays another team. And there's lots of additional properties associated with that link. So for example, the location where that match was held, which team won that match, and by how much, and then the date and time of the match too. So the enrichment of the data is on the links in this case, and we're going to show you a couple of different ways that that can be helpful to visualize in graph data. So I've set up an architecture here to create an interactive web application to be able to kind of work our way through this graph data. Now, I'm using our products at Cambridge Intelligence called Keylines and KronoGraph to show this, but the concepts really apply regardless of what types of end-user-facing applications or toolkits you're using. But this is kind of the flow of what happens when I work with that graph data from within the browser. So in Keylines and KronoGraph, which I'll show you in a second, it captures those mouse events, the things that the user wants to do. They'll click, double-click, hover, drag, drop. So in this case, I'm capturing a double-click event. The browser is then, it's passing it to the browser, which then in the JavaScript in the browser turns into what the user wants to do with that click. So They say, well, when the user double clicks on this, they want to search for that node back in my database, or they want to expand on it, find me the other things that are connected to this item, and so on. Now, that passes it back to Node.js running on the server side to turn into an actual query. In this case, say, the gremlin query that it's going to hand off to CosmosDB. Now, we want to run that on the server side because we don't want the browser to know exactly and be able to formulate gremlin and pass those things off to the CosmosDB server. That's a big security hole. So in this case, the browser is just understanding what the user wants to do. The server side is translating that into the actual query that has to run over on CosmosDB. So this is the gremlin that gets generated. I truncated it here, but effectively go find the match where one of the teams was England and so on. Now, CosmosDB is going to turn around then, take that query and turn it into a bit of JSON, which is all of the nodes and links that meet that criteria that you've passed on. And then we're not going to do anything with it other than just pass it all the way back from the server to the browser and from the browser back to the keylines and KronoGraph, which are then going to turn that back into a visualization that we can use and that an end user can understand and work with. That way, your end users, the people who are trying to make business decisions based on the graph data, don't have to know anything about Gremlin. They don't have to know about the architecture. They don't even really need to know about your data model, what are nodes and what are links. All they have to do is say, show me all the teams that England played in 2017, for example. So let me show you a little bit about how this is going to work. I don't think it makes sense to go too deep down into the JavaScript in this case, but I do want to show you a little bit. So I've got the Cosmos router up here. This is the piece that's running on Node.js, which is taking the query from the browser side, show me all the matches in England in 2017, turning that into the gremlin here, which I have some query templates here, which you can read, and then passing that back to CosmosDB via the endpoint, which Cosmos exposes. So then what do we get when we do that? Well, we get an example here. So let me start from the beginning. Instead of bringing back 3,800 cricket matches all into the browser and trying to visualize those all at once, that's not going to be particularly useful. What I'm doing is starting from a query. Now, for the purposes of this example, I put the query here on the tab in the browser itself so you can see what it is that it's doing. But it's the same query that I showed you back in the source code. So in this case, it's saying, show me the cricket team England and all of the matches that it has played. So there's a couple of things to note about the styling here. I'm getting the raw data back from CosmosDB, which says, these are the matches that England's played over the time period that I've asked for. Now, England may have played India, for example, several dozen times, but that's reflected just as a single link. Because as you saw in one of the examples I showed earlier in the slides, it doesn't always make sense to draw a separate link for each individual instance. In this case, drawing 200 separate lines, for example, between England and India is not going to help anybody understand what's going on. The other things I've done with the styling is I've used the flag of the country in the upper left of the cricket bat icon, just as additional information about and visual styling about the teams that we're looking at. On the right-hand side is an expand icon. I'll show you that in a second. But then down here at the bottom is what we call the time bar. What that is it's a way of looking at the time data that we've brought back. So I mentioned that England and India may have played each other several times over the course of the time period that we've queried. It is helpful to know exactly when that is. So in this case, we can see that there were a few matches in the 90s, then nothing throughout the early 2000s until 2008 when they started to pick back up again. So we'll take a closer look at the time bar and how that evolves after we go through a bit more detail here. So the other thing that we have in the styling here is what we call a donut. That is a way to show the win-loss ratio of each team. So I mentioned that the links themselves contain information about which team won the match. When we bring back several of those, we can see whether a team itself has a winning or losing record. So in this case, the data that I happen to bring back for for England shows that them winning the vast majority of the matches. And it shows India winning about a third or so of the matches that they conducted during this time period. So that's a helpful way of summarizing groups of data, in this case, several different matches, in a single representation on the chart, so the user can see which teams have a winning record, which teams have a losing record quite easily. The next thing that we're going to do is expand. So I talked about how we're not bringing back all of the data at once into the browser. That would just overwhelm the user and make it more difficult to understand what it is that they're looking at. So in this case, we are allowing the user themselves to guide their exploration through the data. So if I want to expand on India here, I have double-clicked on India. That's created that gremlin query that says, go back, find me all the matches that India has conducted over the time period, and bring those back onto the chart. And you can see that we've added them both to the chart and to the time bar here at the bottom. What this allows us to do is to allow that user to better understand and guide where they want to go with the data. Now that I've seen who's India has played, let's take a look at Kenya. Now I've brought back the countries that Kenya's played, and now I've brought back the countries that Canada has played, for example. The time bar is showing me a bit more detail now, too. The blue shaded area is the area that's showing me all of the matches that were played, of everything that's on the link chart at the moment. But when I select an individual, say, for example, Canada here, we can see that they didn't play any matches, international matches, until 2008, where it picked up and then dropped back off again from 2010 to 2014. So it gives us detail about both the sum total of the data that's on the chart, but also the temporal patterns built in to the individual nodes and links that we have selected. And that allows us to really understand what it is, the detail of what it is that we're looking at. The other piece with the time bar that can really help when you have these temporal patterns is to be able to filter the chart, the link chart, based on when certain things happen. So if I wanted to show me, say, only the nodes or the matches that took place between 2003 and 2005, I can see those by filtering the keylines chart. So now I have zoomed in on that window, and I have shown only the teams which participated and the matches which took place during that window. I can also play back. So if I wanted to watch how cricket matches evolve over time, which teams got more active, which teams became less so over the course of the time window that I'm inspecting, then that can be a really helpful way of understanding how my data itself is changing over time. So this time bar is one way of looking at that time dimension. What it's doing is it's allowing us to understand frequency of events. In this case, each match has a specific point in a date and time that we can look at. And as we accumulate those and add more and more to the chart, the time bar is showing me which areas have lots of activity and which areas have fewer. But what it doesn't do is give me any sort of sequential understanding of events that happen over the course of time. So I can't see, for example, that Canada played Kenya and then immediately played Ireland afterwards in a certain, say, 2-day period. So what I'm going to do now is I'm going to switch to another example of a visualization that's still looking at graph data, but is less about the what, less about what's connected to what else, and more about sort of when those connections happened. So this is a different product that we have called KronoGraph, which is just effectively graph data and looking at graph data and how it varies over time. So in this case, we've got all the same teams. I've brought back all of the teams instead of just a smaller number of them. And we have these heat maps for each team showing when they were the most active. And we can see some pretty interesting examples here. So New Zealand, for example, has been active over the entire course of the several decades that we have in the data, whereas we were looking at Canada earlier. Canada did not really become active until 2006 when they started showing more matches. So this, when we look at it at the heat map view, we don't have that connection element. We're just showing, New Zealand played this number of matches at this point in time. Canada played this number of matches at this point in time, but we don't understand who has played what else, whom else, and when. So then what I want to do is I want to allow the user to see those individual items. And I can do that by zooming in to certain windows of time. So you see that as I zoom in to now look, say, just at an individual 2-year period, I can see that there are many different events clustered together over various windows of time. So I can see, for example, that there were many matches here in March of 2005 between the same two teams, and the same between Australia and England in May and June of 2005. So this allows me to really kind of understand those temporal patterns and the sequence of events as they occur over time. Now, it was a bit too much to kind of understand that all at once. And even this view is a little bit cluttered. We're still not quite understanding individual data elements and how they might be connected to one another. So let's zoom in on a specific team here. So now I have Canada and specifically their matches, and I'm excluding everybody else off of this chart. What that allows me to do is to see their activity filtered from everybody else's. So we can see only who they have played and when those matches happened. Now, what I've done here is I've taken the winner of the match, and I've used the arrowhead to indicate that. So an arrow points away from the team if they are a loser and toward the team if they are a winner. So you can see some instances where things go in both directions. So they played Bermuda several times in 2007. It looks like they won most of those. But in many other cases, it looks like they didn't. Canada is not exactly known as a cricket powerhouse in international cricket. So what this allows us to do is to really better understand both the temporal patterns in a complex data set, both at a high level, just when were certain events happening, and at a low level, who was involved with those events. So we've talked a little bit about the time dimension and how that can be useful. I also want to take a step back and look at the space dimension. So here I'm going to move away from cricket and just show you another example here. So in this example, we are still looking at graph data. We're looking at a stylized example of, say, a stolen car in New Jersey and New York, and has both a location component associated with it, where was this car seen, where were the events happened, and a temporal association. So when did those sightings happen? And so we're taking a graph link chart view, superimposing it on top of a map so that we can see specifically where did these things happen, and also the KronoGraph view of what are the connections between those events and when did they happen. So we can see, for example, that there were several license plate sightings of this car in the early morning of the date that we're looking at in 2007. Then there was a robbery, and then there were other license plate scans of that car later on over the course of the day. And we can see spatially where those were in Manhattan by looking at that over the top of a map. But one of the things that we haven't yet done is that we haven't brought this multiple data sources into the same visualization yet. So the cricket example was just one upload. It was actually even just a single table. It had the teams that were playing, the matches, and when those matches happened. However, one of the powers of doing visualization like this is that you can draw from multiple sources and bring those all into the same visualization at the same time. So you could bring data back from CosmosDB, for example, but also from, say, a local store, a local database you may have, or even just something like a spreadsheet or a local file, and combine those together into an overarching view of the data that you have. So by doing that here, we're going to add in another source. We're going to add in a source of phone calls. So now you can see our KronoGraph view has become a little bit more complex because we're looking at phone calls made by this suspect as the car was stolen. And we've extended it a little bit to show earlier on the previous day as well. Now I can zoom in. I can zoom in and see when those phone calls happened. I can even see specifically, once I get to a certain level, who he was calling to. So there are the specific numbers that that individual has called, when they happened, and I can correlate that with the locations. So as I get to June 18th, when the robbery happened, who was he calling at specific points in time around the time of the robbery or around the time that the car was spotted at certain locations? So certain numbers may stand out. So what I'm doing is I'm combining sources both from my CosmosDB database and bringing that into both a temporal and a geospatial visualization. But I'm combining that with phone call data, which doesn't have either of those. I'm sorry, it does have the temporal visualization, but it doesn't have the geospatial component. But by working with those together, you get a really good sense of what happened during this event. Okay, there's one last thing I'm going to touch on here, and that is what do I do when I get too much data? You can kind of see where we're going with this, but the examples I've shown you so far have contained up to 3,000 links, which we've had summarized into just a single connection between a few dozen teams, for example. CosmosDB is very famous for having large scale, and you can operate at a huge volume. But how does that impact our ability to visualize the data? What happens when I get millions or even billions of records? So to some extent, the expand theory that I showed you earlier, which is don't bring it all into the browser, try to allow the user to guide their exploration through the data, can be really powerful in that situation. We're not looking at everything. We're looking at specifically what the user wanted to see and let them expand out or explore their way out from there. But another way of working with that volume of data is to do what we call combinations. And that's a way of looking at groups of data and how those groups themselves are connected to one another. So this is an example where we have nodes which are members of Al-Qaeda and intercepted communications between them. And it's a bit complex. There's about 220 nodes on the chart, but you can kind of understand a little bit by looking at the node link diagram, who the key members are of this group, who the most well-connected members of this organization based on their links to other members of Al-Qaeda, for example, and so on. But as you get more and more data on the chart, it doesn't make sense to take each individual person and plot them as a separate node. At some point, it becomes just too much for the user's eye to understand and make sense of and get any actual value out of. So these combinations, what they allow you to do is to group together based on any property and then show how those groups themselves are connected to one another. So in this case, you saw I used the flag, just like I did with the cricket matches, of the country where that person lives in to create an ornament around them on the chart and give the user some more information about where they're from. However, that's also a property of that node in the underlying data. So now we can group together the nodes by the country of residence of the individuals that are inside of them. And we've also sized the node to show me the relative number of individuals inside of each country. The width of the link is also now showing me the number of connections between members of those countries. So we can kind of have a more geopolitical view of this data. But the underlying data is still there. I've brought all of my data from my data source into the browser to be able to do these groupings. So what that means is that as an end user, I can zoom in and still inspect the underlying source data. So for example, here, I have Malaysia. I have my individuals inside of Malaysia, how they're connected to one another, both in the country, but also externally. So I've selected somebody here. He has connections to other Malaysians, but then also to people in Afghanistan. So this grouping feature can be really helpful when you have a lot of graph data that you want to summarize and present to an end user in a format that allows them to better understand what they're looking at. And it can even go multiple levels deep too. So if I wanted to, say, take the country nodes and group them together to create sort of these super groups based on the continent that those countries are in, then I can do the same. So I've taken what was originally 220 nodes and combined them into a group that, or into a visualization that only contains 7 nodes on it. But just like I showed you before, all the detail is still there. So Europe gives me the countries in Europe, and then say zooming in on France will give me the individuals inside of France, their connections both in France to other countries in Europe and to other continents on the globe. So this summarization, I think, can be really powerful because it does allow you to take that huge volume of data that CosmosDB is famous for being able to process and contain, bring that, some of that, into the browser, and then allow the browser to do the summarization to allow the user to make sense of it and understand it without having to overwhelm them with graph data that just doesn't help. So I'm going to switch back to the slides now and just kind of talk a little bit about the products that I've shown you today. So I've been showing you Keylines and KronoGraph. So Keylines is a network visualization toolkit that we provide here at Cambridge Intelligence. We license to our customers to build graph visualization applications containing that UI, that interactive UI that I showed you over the course of this example. Now, we also have a few other products. reGraph is one, which is similar in that it's a graph visualization toolkit, but specifically built for users who are using the React framework. And then KronoGraph was the timeline visualization toolkit that is actually a brand new product for us. It's only been out for a few months, and we are actively seeking feedback. And we do provide free trials of any of those if you're interested in trying them yourselves. Please feel free to reach out to me. Thank you very much for your time. I hope this was helpful in understanding things that you can do and techniques that you can apply to your visualizations, regardless of whether you use our tools or not, to help understand how to expose users, business users, to graphs that have a temporal dimension and a spatial dimension. Thank you very much.